students. Today, I will just explain to you the concept of tachometer. A tachometer is similar to your normal theodolite, which we had discussed in the third semester. The theodolite measures the horizontal as well as vertical angle. Similarly, the tachometer that we are going to use for our distance as well as elevation difference computation is similar to your theodolite. So we also call tachometer as a normal theodolite. It's no confusion as far as these terminologies are concerned. Now, tachometer, where it is used, basically, a tachometer is an tachometric surveying is an angular form of surveying in which the distances and differences of elevation can be obtained but not very accurately. It's an approximation that we have, especially when we are measuring longer distances, the approximation increases. Okay, that's why tachometer is a tachometric survey will be utilized for smaller areas only, smaller area topographical map preparation, and also for preparation of engineering maps which are needed for your route alignment as well as for your pipeline alignment laying. These are our civil engineering applications. Now, what we have to see in this tachometer is we have got three cross hair, okay, and when we take the reading of these three cross hair using a leveling staff on the ground, the difference between the top and the bottom crosshair reading is what we call as the staff intercept, that we are abbreviating as S. Okay, but in our normal stadia based tachometry, we are only seeing that the staff intercept varies with distance. We will not alter the crosshair differences in any way. This is not permitted in stadia method of tachometry. So today we are discussing only the stadia method of tachometry. Now please pay attention to this figure. This figure is a figure in which the reading has been obtained from point P to a point Q. Now point P is where we have kept our tachometer or theodolite, and then the leveling staff is at point Q. So the small vertical line that you see is a leveling staff. Now we have taken the reading from P to Q, and yes, that is the staff intercept, but what I was telling, the difference between the top and bottom here reading is S, that is the staff intercept. Now, because Q is at a very higher elevation compared to P, the line of sight is not going to be horizontal. So line of sight will be inclined, and it is inclined upwards. That means the point P is at a lower elevation compared to point Q. So the angle of elevation is what we are observing, because the point Q is at a higher elevation compared to point P. Now, theta is the angle of elevation that we have obtained. Now, from point P to point Q, horizontal component is D. This horizontal component is what we are using for carrying out the plotting for preparation of maps. So that is D. Then the inclined component is L. Inclined component is L. Height of instrument is small h. The reading of the central wire, the central hair is R. That is from central wire to the bottom of the leveling staff is R. And this imaginary line, the horizontal imaginary line is there. That is the line from there to the central point here, that is capital V. So these are all the nomenclatures that we have in our figure. This nomenclatures means once you have seen, we can obtain the equation in which capital D is equal to K into S cos square theta plus C cos theta. So this is the formula that we have to derive and obtain it. This derivation is a very simple derivation, and C here is the additive constant. The value of C you can take as 0.3 to 0.4. But if you are having a telescope in which analectic lens is provided. Now what is an analectic lens? Analectic lens is a convex lens which is fitted in the telescope. In between the objective and the eyepiece at a fixed distance from the objective. So this analectic lens, when you are providing, then the value of C will be 0. Okay? The value of K is a constant, so that is 100. Okay? Now V is what we have seen in the figure here. This V, that is from the horizontal line of sight to the central wire reading, that is V. So that V has been obtained from the derivation as equal to K into S. S is the staff intercept. Here also S is staff intercept. Staff intercept means what? The difference between the top and the bottom wire reading on the leveling staff. So A is known, S is known, theta is known, C is known. So everything is known. So we have to substitute and obtain either the value of D or the value of V. So this is what in a nutshell we have to carry out for the inclined line of sight. The inclined line of sight means either it can be an elevated angle or a depressed angle. There is a vertical angle will be an elevated vertical angle or a depressed vertical angle. Now you please see this particular figure once again. The elevation of Q, that means if I know the elevation of P, I should get the elevation of Q computed. That is what the idea is all about. Now elevation of Q, which is not known, the elevation of Q is equal to elevation of P. Please see the figure. Elevation of Q is elevation of P plus H plus V minus R. So that is what is written here. Now sometimes what happens, the elevation of Q will be known, elevation of P we have to obtain the problems. So in that case, if the elevation of P is to be obtained, then elevation of Q plus R minus V and minus H. That is what is given here. So this is how we can either throw the elevation or we can bring back the elevation of our own instrument station. So this is what is possible in our tacheometry with inclined line of sight. Now come to the second figure here. The second figure is the figure for the depression angle. Theta is a depression. The vertical angle is a depression angle here, as you are observing here. Please observe the remaining nomenclatures are all the same. Okay. Only thing is, in this case, the elevated angle, the vertical angle is the depression angle. So, if the depression angle is the vertical angle, then elevation of Q here is elevation of P plus H minus V minus R. So, that's all the change that we are observing. So, just draw the figures, you will be able to obtain the elevation as according to whatever your requirement is. So, that is what we are required to see here. Now, come to one problem. So, the problem part, numerical part, we will have a numerical like this. So, like determine the gradient from point A to point B for the following observations. K is equal to 100, C is equal to 0. Instrument is at P, staff is at capital A initially, and afterwards it will be at B. Bearing, he is giving the third column, he is giving the bearing. What is this bearing? Bearing is a horizontal angle. It is not the vertical angle. Please observe. Whatever we have discussed earlier, they are all the vertical angles. Theta that we have seen there in that equation is the vertical angle. But in this problem, we have got the bearing. Bearing from P to A and from P to B. From P to A it is 134 degrees. From P to B it is 224 degrees. Bearing. Vertical angle is given 10 degrees 32 minutes, 5 degrees 6 minutes. See, he has given the nomenclatures plus and plus. That means both the angles, vertical angles, are angle of elevations. Now, from P to A, we have got three staff reading: bottom, middle, and top. Bottom, middle, and top staff readings are known and observed. From P to B, the same thing. The staff reading will be bottom, middle, and top. These readings are entered here in this column. Now, what is that our requirement? We have to get the gradient from A to B. From A to B, we have to get the gradient. So, this is the question that we have got. Now, how to solve this? We have to solve this kind of problems in 2 or 3 stages. Now, first stage is when you have to make an observation from P to A, because initially you make an observation from P to A. Now, we are making an observation from P to A. Then, just see the relevant data, that is what you are observing for observation from P to A, the relevant data you are observing. Now, D is what? From that is the distance from P to A, that is K into S cos square theta, the standard formula plus C cos theta. This particular formula was derived in 3rd semester. That is K is the staff intercept, K is the constant, which is 100. S is the staff intercept, that is 2.470, that is the top wire reading minus bottom wire reading, that is 1.360. 2.470 minus 1.360 cos square, that is 10 degrees 32 minutes. See, this is how it is. Plus, since C is 0, C cos theta component will become 0. Okay, because when you put 0 here, everything gets become equal to 0. Okay, that is what is 0. And when you simplify this, this will be 107.3 meters. Similarly, when we have this analogous to this particular figure, because it's angle of elevation, plus sign is angle of elevation, minus means angle of depression. That is how we have to observe. V is k into s sin theta by 2 plus c sin theta. So relevant substitution 100 into s is the same thing, 2.470 minus 1.360, okay, into sin 2 to 10 degree 32 minutes by 2 plus 0, that is 19.95 meters. Similarly, when you have to do the observation from P to B, same thing, we will have D as 162.7 meters and V as 14.2 meters. Now, after you do the computation of D and B for both the observations, that is from P to A as well as from P to B, then you draw the figure, because the bearing is given to you now. See the bearing is given roughly 134 degree is coming somewhere here from P to A. Next 224 degrees coming somewhere here from P to B. Now what is this included angle now? The included angle is 224 degrees minus 134 degrees, that will be 90 degrees. This is 224 degree bearing and this is 134 degree bearing. 224 minus 134 is 90 degrees. What is the distance from P to A? The distance from P to A is 107.3, which we have calculated here. Please see here. Now the distance from P to B, which we have calculated as 162.7 meters. Now this is the triangle that you have observed. Here this length is known, this length is known, this included angle is known. Therefore, the distance between A and B can be computed using the simple formula given here, and that distance between A and B has been worked out as 194.9 meters. Okay. Now the objective is to get the gradient. The gradient is how much rise or fall is there for this distance of 194.9 meters. How many meters of rise and fall is there? That is what is the gradient. Now for 194 meters there will be some rise and falls, but for 1 meter how much is the rise and fall? That also will give an understanding of how much rise and fall will be there for each meter. Okay, that is what we express as gradient, 1 in x, 1 in n, like that. Okay, that is what we have to know as gradient. Now that is what we have to calculate. Now observe here the difference of elevation between capital A and the instrument axis. See, treat this as capital A and the instrument axis. This V we have calculated as 14 point, what is that, how much we have calculated? That there it is 19.95 and minus the central wire reading. Okay, so that is 1.915 here. 1.915, that will be 18.035. That is the difference in elevation between the instrument axis and the elevation of point A. Similarly, the difference of elevation between point capital B and the instrument axis is 14.521 minus 1.865, that is 12.636 meters. Okay. Therefore, we have to get the difference of elevation between A and B, which will be given as 18.036 minus 12.636. We have got the difference elevation between instrument horizontal axis and the point A, instrument horizontal axis and the point B. Therefore, the difference in elevation between A and B is whatever 18.035 minus 12.636, which is some value, and that difference of elevation is for a total distance of 194.9 meters. Therefore, gradient between A and B, rise and fall between, for 1 meter distance, will be 18 point, see, same thing I have transferred here, 18.035 minus 12.636 divided by 194.9. That is for 194 distance. The difference of elevation is 18.035 minus 12.636. Therefore, for 1 meter, we have to divide it by 194.9 meter. That will be 1 in 36.1. That is, the gradient from A to B is falling at a gradient amount of 1 in 36.1 value. Okay, so that is how the gradient is expressed. So this is how the problem of tachometer is going to come, and we have to solve in this way. Thank you.